Okay, then we're gonna get into true size and shape. Of course, we'll take a look at the inclined planes. Alright, so usually the very first problem that we solve is a true, size and shape, and we usually start with the inclined surfaces in solving auxiliary projection problems. So you will see this type of problems, often. So our field is we design geometric features. Some students still, need to review your probably middle school, I think, geometry. Maybe some schools start from elementary grades. So make sure you review the geometric structures. Triangles, holes, slots, right? Dealing with inclined or oblique surfaces, because drafters, designers, engineers in the design area, we call it design engineer, right? Technologists usually work very close to the design engineer because they master mathematics, more than the pure tech staff. So this is where you're going to come in, your CAD system operators. Most likely, if you do not have the engineering or engineering technology background. Okay, so anyway, so we work together. When we deal with the inclined or oblique surfaces for any of the models, geometry features, and we features like your circular holes or elongated holes, those kind of features, we usually dimension them, in views. Of course, you definitely keep the true size and shape characteristic with them, and we usually, call these views normal views, which you can be able to perceive where your line of sight is perpendicular, to the plane. Here are examples of inclined surfaces. We can see right here, 1, 2. Of course, so this object is standing on this base. So you have a first incline, second incline surfaces here, and this is just a chunk of it looks like line here, but an inclined surface, of course, because it has some sort of angle on the base. Reiterating, this is the same, your triangle, and of course that's your front, and then this is your right side is appearing as a line, and this, you can see this is a one single planar surface, and the other side goes another planar surface, and this is your right side, and that's your front side. We get into the views. Usually problem is going to ask you to solve for the true size and shape of the triangle when you change views, of course. And we usually do what we do, we verify the projection. We're going to connect all the points with parallel projectors, and then we will label the points. So let's see how we do it. First, we start with a full line, some location between two views. So this is your front view, and that is your right view. So I'm just gonna put front here, and this one is your right. We're gonna start verifying the projection to this view. So let's insert a full line. We inserted it right here. You have your projectors, so 2 line. I'm gonna do that again for you. Projectors. We're gonna insert a full line, perpendicular to the projectors. So when we draw, that's how you start. First, you're gonna start with this line, second line, and then your full line is the third one, which is perpendicular to the projector line. This is your projector line, and that is your full line. And that full line got to be some location doesn't say at the center. So I remember one of the students, oh, do I have to put it in the center? No, you can put it in between, yeah, this view and that view, two views, anywhere, okay, between the two views, anywhere. And then the concepts, let's recall, yeah. So the incline problem, it's gonna always project an edge view, your line, okay? Don't forget the edge view is kind of like look like a line, and you can always project the true size and shape view of a planar surface from that edge view, okay, of that planar surface. So if you project perpendicular to the edge view, that's what you're gonna get, yeah, the true size and shape. So in a simple way, we usually get the edge view, yeah, when all the points and the lines are aligned to a single line view. So every time you think about the edge view, just remember it looks like a line, yeah, a single line. Don't forget they are to make the edge view, yeah, the lines going through the points on a plane are parallel to your line of sight, okay? Right now you can get it by reading it with very little background on drafting. You're gonna be thinking, hey, what are these? Yeah, my brain is not gonna be catching all of it. You can't right now, okay? Just try to get it. Only yes, this much for now. And when you see the projection, we have only 6 views anyway. Again and again, again and again, then you will get it. Yeah. Automatically you will get it. You have to trust me on that. Alright, the same thing, true size and shape problem, inclined plane. We have our front view and then your right view, yeah? So we start out with the projectors, and that's completely perpendicular to the edge view. When you take a look at it, you see only a line, right, of this guy, but the projectors are definitely perpendicular. One moment. Sorry, to the edge view. So when dealing with a single plane, yeah, or surface, doesn't matter which direction you project, as long as your orientation or the projector is perpendicular to the edge view. Okay. So again, first we're gonna construct the projectors from the edge view. How we gonna construct it? Some students don't understand this dash. This is just telling you this is how we're gonna construct the projector. So it means that projector is gonna be oriented perpendicular to the edge view. So you already know this. The edge view has got to be perpendicular to this. Okay. So let's see the drawing. So here we go. Yeah, we put it in. See? Projectors oriented perpendicular to the edge view, your right side view. Then insert a full line at some location along the projectors. And every time you read the example problem, like pay attention what's saying. Don't just read it like whatever. This is not English, by the way. It is written in English language, but you gotta be so careful about what you're doing each step of the way, and don't do anything more than what it is saying here. Yeah, so it's an insert a full line. So we're gonna insert the full line at some location, yeah, along the projector. So that full line gotta come some location along that projector we just draw, oriented perpendicular to the edge view. Okay, so let's take a look at it. So some students are thinking too much or not thinking with the problem. I don't know how you think, but I have encountered many students jumping in the thoughts. Yeah, you have to get rid of everything from your head when you study. Yeah, so that's the first thing you gotta do, and your concentration gotta be 100% on what you're doing currently, and don't think any other thing than what you see in the problem. Okay, don't have a scattered thoughts. Are very important in scholarship. Okay, so let's see how we do that. So we're gonna draw this. Yeah, bang. So perpendicular somewhere, of course, on the line, yeah, of this projector. And that projector, we already draw it perpendicular to the edge view. So that's a recall, right? What we did for the measure and transfer method that we studied in Unit 1. Then we do the same thing. We are going to measure and transfer, yeah? So we will measure the distance from the vertical full line to locate point. We have 1, 2, and 3 here, yeah? So this is our, yes, and numbers indicating these edges right there, yeah? Point here, point where they intersect, yeah? Then we're going to transfer that information onto the next auxiliary view, which is going to be, yeah, your top view, because we've got the front and then the right side here. So front view, your edge view, which is your right view, okay? And now we're going to transfer the same, yeah, size and shape to the top view by using the measure and transfer learned in Unit 1. So we're going to transfer, yeah, information. I have 1, 2, and 3. We already did it from 1, 2, 3 to here already, yeah, given that in the beginning of the problem. Then we start projector and then the full line, and we're going to transfer that to our last view, which is the top view. And we usually call the second, yeah, view middle view, because you will be using that view to transfer the information to the third one, okay, or the last view. So your right side view, your front view, and your right side view is the middle view, okay? And we call it view in the middle view, the same thing. I just go by middle view. And we're going to use the middle view to get the lost or the new, right, view away from that. We do the same thing, yeah? Here is your projector. So we're going to move it, extend it all the way up, yeah? So this arrow is just showing you, please extend. Let's go back to the previous slide so you can see. So this was before, and now we're extending out, yeah? So this is, since this is a right view, we have 2 points going on, yeah? So the very first point, yeah, is number 1. So we're going to start with the 1. And you're going to go extend, how much do you have to extend past this full line? You're going to extend the same distance. So from here to here, you have already have your measure, yeah? So that's what you're going, and then you're going to stop it. Since this is a 0.3, yeah, the same thing, 0.3, yeah, got to be away from this 2 point, the exact same distance, okay? You can't put it here, because if you put it, your let me draw it with this little, if you stop your 0.3 here, yeah, and when you draw from here, it would have been a different distance from this guy, yeah. And if you draw from here, if my point of view was there, it would have been really different, yeah, measurement. It won't be the same as this 2, 3 distance. See how long that is. So you gotta keep moving until you get that correct. All right, we call it true, yeah, size and shape. Yeah, right now I'm kind of wiggly because I'm drawing, yeah, roughly. So anyway, and that you have to do with your ruler, yeah, and your precision accuracy are very important in doing, yes, in doing this transfer method. And finally, we're gonna connect, yeah, all of them. So connect 1 and 2, 2 and 3, and then 3 and 1. So, bam, this is your top, yeah, your horizontal view. Another way of calling what's given to you, front view and right views are given to you. We call them parent views because we're producing the last top view from them. Okay, so this is your child or new view. This is your middle or your parent view, and this is your front and the parent view. The middle view can be this one too, yeah, if you transfer this to the other side, yeah. So whichever way you want to go. In this case, we're going from here to there and there to there, yeah. So this is your middle view. Don't just keep things definitively like the right side view always got to be the middle view. No, that depends on your problem. Okay, so read very carefully what you're reading and recognize what you're reading and think with your brain what you're reading. Okay, so studying is it's not easy because you're kind of meditating, you're kind of concentrating, and you gotta put your brain and your thought 100% into it. Okay, so here we are. This is our new auxiliary view, and make sure you erase, yeah, all of your transfer lines in between three views. And we call this a true size and shape because it resulted in it. Yeah. Okay, well, that's it for the true size and shape incline problems.